Right, so looking at this, you got the floor here. It goes, you got a force of 345 newtons applied to the floor. The force is to be to the nearest 5 newtons. Obviously, force equals pressure equals force over area. Now it says work out the upper bound of the pressure. Give your answer to 4 significant figures. Now, when we're working at upper bound, first of all, this has been rounded to 5 newtons. So if I put 3, 4, 5. Now, when this has been rounded to the nearest 5 newtons, what you do is you get the 5 and you divide it by 2, which gives me 2.5. And then from here you do plus 2.5 to get the upper bound, and from here you get the minus 2.5. So the upper bound for the force is going to be 347.5. This is upper bound. The lower bound is going to be, take that away, is going to give me 342.5, which is the lower bound. Now when it's divide, when we're doing this, we want the upper bound, because we want the upper bound for the pressure. To get the upper bound, we need the upper bound for the force divided by the lower bound for the area. Now you've done some of this before. That is the way you're going to get the biggest value. You can't use upper bound divided by upper bound, because that's just not going to give you the upper bound of the value. Okay, so just remember, if you got 10 and you divide it by, let's say 10, that will give me 1. But if you get 10 and divide it by 5, that's going to give me 2. So the smaller you divide it by, the smaller the number on the denominator, the bigger the value you're going to get. Okay, so this has to be the lowest value you can get to give me the highest value. Okay, so I want the lower bound of the area. Now in order to get to lower bound of this area, I want the lower bound of here. Now this is to the nearest meter. Again, you could get 0.1 divided by 2, and that gives me 0.05. And you could get the 2.6. To get the upper bound, you add the 0.05. So the upper bound gives me 2.65. And minus 0.05, the lower bound gives me 2.55. Likewise, you could do the same thing here. And I'm not going to put it in too much wording, so that becomes the upper, you want the lower bound, so that you're going to use 2.55 for the width, and I'm going to take away 0.05, so I'm going to get 6.35. Now just to state that and state that, you get 1 mark for that, 1 mark for that. Okay, so some of you that did that might have got a 1 mark or 2 marks, so it's always important. You would have got also a 1 mark for here. So you got 3 marks already without even doing any calculation. It's a 5 marker. So first of all, to get the lower bound of the area, you do 2.55 times 6.35. So if you all do that, I'm going to do it. 2.55 times 6.35. You got to get 16.1925. Now somebody did that and then rounded it. Please do not start rounding things. You can't do the rounding until the last moment. Okay, you don't do the rounding yet. So now if I want the upper bound to forcing with figures, first of all the upper bound, so pressure upper bound, sorry, didn't mean to write pop, so that's going to give me 16. So the force, sorry, the force, the upper bound for the force is 347.5 newtons. Okay, and the area, the lower bound of the area is 16.1925, and obviously that's in meters squared. So when I want the upper bound for this pressure, let's just do that now. 347.5 shared by 16.1925. You got to get 21.46055, etc. I want it to force in the figures, which is 1, 2, 3, 4. So my answer, I just put it here, pressure is going to be 21.46 newtons per meter squared.